Yeah, just 5 and 6. Okay, so we're going to pick up where we left off. We did 1 through 4, and let's start with 5. Give yourself a minute. I would recommend writing it down. This is the only word problem we're going to do for this concept. I know we've been doing a lot of word problems in the other ones, but for this one, there wasn't too much of an application there. So we're going to say an object is pushed along a rough surface. So any given object. Let's take a look. Let's start with this box, for example. So an object is pushed along a rough surface. The friction function is defined as f of t equals 5 over t minus 2. And the push function, what does a push function mean? Me push, very good. Again, it's being pushed along a surface, so the push function is me pushing this. Is defined as p of t equals 2 over the quantity t plus 3. That's a comma there. Just because other classes thought it was a square, that's a comma. Okay, in case you can't see in the back. There's a comma right there. It's not square, it's just a comma. I know it looks like square. They are equivalent when the object is moving at a constant velocity. What does that mean, first of all? Let's think logically. What is constant velocity?
Same rate.
Not changing. Good. Constant is unchanging. Just like a graph that is a constant graph is a horizontal line. It's unchanging. Okay? So the idea is this. If I push more than friction pushes back, the object's going to accelerate. And that comes, if you remember from physical science in 9th grade, that's Newton's laws, F equals ma. If my push is more than friction, it's going to accelerate. But if my push is pretty much the same as friction, you're going to notice the box will move at a constant velocity across the ground. But the minute I push harder, it's going to accelerate and then top lower. So for an object like this, if I'm looking at it and I say, okay, well, why did it stop? Because friction slowed it down along the way. Friction slowed it down here. But if it's at a constant velocity, it means that my push and friction are balanced. So the problem is asking us, determine or find the time t when the object's velocity is steady. Well, what does the word steady mean then?
Constant.
It means constant. It's the same thing, doesn't it? Something that is steady is unchanging. Something that is constant is unchanging. So the problem has two different words here, and this is an example of an SAT problem. You have velocity is constant and velocity is steady. It means the same thing. Now, we're told again that the friction function and the push function are equivalent. What's another word for equivalent? The same, very good, or equal. So does anybody have a proposition of what I can write here? What can I write on the board to start? Karen? Good, 2 you meant, right? 2 over the quantity t plus 3, right? That whole quantity. How come you did that, Karen?
Because it's constant and it's steady. Oh, it says it's equivalent.
Good. The key word here is equivalent. Notice, the functions are equivalent when there's a constant velocity or steady velocity. And the problem says, find the time that occurs when there is a steady velocity. So this kind of a problem is exactly what we've been dealing with. We're trying to determine the value of t. It's in the denominator, so we have to go through all of our steps. Before we start, what might the common mistake be here? What is the common mistake?
The child wants to multiply like 3 or something.
You want to multiply 3? Where?
At the bottom of that other side.
Here?
No, the other side.
Here.
Yeah.
So why would you put just a 3 here? Why is that a mistake?
Because it's a mistake because that whole thing is added, and so then you have to add an x plus b and move that side and t on that side.
Okay, so what Melissa is saying, to summarize, is this. The common mistake some students might do is they say, I want a common denominator, so I'm just going to put a plus 3 there, and then, like, denominators are the same for those two. But I can't do this, because remember, you can't add something to the value of the top and the bottom. You must multiply by that on the top and the bottom. So this is not mathematically sound. So we can't do that. So we start with saying, okay, let's look at our denominators. What's my denominator here? So start by thinking of that one. Good. What's my denominator right here?
1.
Good. 1. Remember, there's a 1 there. And over here is just a t. And whenever you want a common denominator, if you don't have anything that multiplies into each other, just multiply them together. So what's missing for my first term over here?
T plus 3 and 1.
Good. T plus 3 and a 1. Do I have to put the 1?
No.
How come?
It's just 1 change.
Good. 1 times anything is itself. What's missing on this end?
T.
Just the t, very good.
What about for the 2? Do you do that?
You put both of them.
Now for here, good Melissa, why do I have to put both of them?
Because they're
Missing
both
both.
missing.
They're both missing. Look, this has a t and a t plus 3. This has a t and a t plus 3, but there's nothing here. So again, I'm just going to move the equal sign over to make this easier. And I'm going to put a t, parentheses, t plus 3, over t, parentheses, t plus 3. Remember, this negative 2 here is really negative 2 over 1. Okay, and we're going to put a little time symbol there. For that dot. At this point in time, what do you notice? Good, they're all the same. And we said, if you take, what was the example, Diana, again? Was it a pear that we used in this class? If Diana's eating a pear, and Melody's eating a pear, they both eat half the pear, they both have half the pear left. So if you cut two things in half, it's the same thing still. So we're pretty much taking this thing, cutting it by a factor of t plus 3. Same thing here, same thing here. So if you do this for all of them, go ahead and cancel. Okay, and remember, this only works when we have the equation here. A lot of people are making this common mistake when it's simply an addition problem, where it's an expression. So if you're simply adding two things together, you need to keep the denominator. But since we have an equation, we can eliminate all of them.
You know, for a negative 2 over 1 stuff, you know that little t parentheses thing you added? How come you don't put the other t in parentheses? How come you leave it alone?
It doesn't matter because it's not a binomial, but you could put in parentheses if you'd like to. If you want to go ahead and do this, that's fine. Parentheses indicate a multiplier, right?
Yeah.
But I need to remember I'm multiplying the whole quantity t plus 3. That's why I put its parentheses there.
Right.
And it helps with binomials because you remember then later you might have to FOIL. Okay, or here, for example, you have to remember to distribute, or here you have to distribute. That's where the parentheses help us for that.
So the negative in front of 2, doesn't that turn into a positive, or does it stay like that?
Well, let's go on to the next line and write it down, and then we'll see, okay? So here we're going to have t plus 3 quantity times 5. We're going to have minus 2 parentheses t, I'll use the parentheses, it doesn't matter again, t plus 3 equal to 2t. Okay, again, I equate my numerators at this point. And now what Mariana just asked was this. Well, what do I do here? You can either think of this as a negative 2, or as we said, adding the opposite. So you could be plus a negative 2 like that also. Same difference, okay? Either way is fine. But now distributing, the first part is the easier one. What does this become? Good, 5t plus 15. But here, a lot of people get bogged down because they see you not only have a negative 2 out front as a coefficient, but you also have this t here. So what can I do for this part? I can multiply what's in the parentheses first. Sure, that's one way to do it. Absolutely.
Yeah.
Okay, that's just negative 2t.
Add them together and then
Okay, but again, do you see an addition sign here, guys? There's no plus sign between them, right? What's between these two, really? It's really a multiplication sign. So this is like having a 2t out front. So Kelly, what can I do?
Would you multiply the 2 to everything and distribute it?
So what do you mean to everything? Explain.
Like negative 2 times c, and then you do negative 2 times c, and then negative 2 times 3. Like,
Let me give you an example of why maybe we can't do that. What if I asked you this, Kelly? What's 3 times 5 times 7? How would you approach this problem?
oh, you do it in order.
You would multiply these, right? Get an answer and then multiply your answers?
Yeah.
So it's the same thing here. Multiply these, it's just negative 2t. So this is just simply negative 2t, and now we have to distribute that to the entire quantity. Okay? I didn't understand it though. Try and use your math words a little differently. Okay? Equaling 2t. You want to talk for a sec?
Can I just get my...
Okay, so at this point, take a look. Notice, this 5 was distributed. We distributed this 5 to both, so we have to do the same thing. But now we have a variable in our coefficient on the outside. There's a variable in that term. So we have to distribute the entire thing. What is that going to do to my problem? Good, we're going to have a quadratic. That's the first thing you want to think of. Because I'm going to have, in this case, t squared. So if I have a quadratic, how many roots do I get? 2. Because again, it's t squared. If it was t to the third, how many roots would I have gotten? If the degree was 3, if it was t to the third, how many answers do I get? 3. Now, they could be imaginary, they could be real, they could be irrational. We don't know just yet, but we do know the amount of roots we're going to get. So here, continuing, 5t plus 15. Now, when I distribute the negative 2t to this, what does it become?
2t squared.
Good, negative 2t squared. And what does this become? Negative 6t. Remember, the negative 2 gets carried to both. The common mistake I see here is people forget that there's a negative here. They leave this as a positive because they see this positive. But it's a negative times a positive, giving me the negative, equaling 2t. Now what do? Who remembers from yesterday? We talked about this. In the back, Leslie. Very good. Whenever you have a quadratic or any polynomial function with a degree of 2 or higher, you want a 0 on one side so you can find the roots. So I really want to get rid of this negative 2. I'm sorry, this 2t here. This 2t on the right side. So how can I get rid of it? Good, subtract it. So on this side, subtract 2t. Okay, subtract 2t from both sides. Now, on this side, I've got a few t's going on here, don't I?
Yeah.
So which one should I subtract it from? Good, Karen, it doesn't matter. Put the negative 2t here. That's fine. What does this become then? This becomes a negative 8t. But don't I have a 5t over here?
Yeah.
So together, what do they become?
1t, 3t.
They become negative 3t. Let's show this because it's a little confusion, it seems. When you combine like terms here, the 5t minus the 8t gives you the negative 3t. Again, take a look. I simply combine these two to give me the negative 8. Then the negative 8t and the 5t yields a negative 3t. And I'm going to put this in order at the same time. Where does the negative 2t squared go? In the front, very good. Negative 2t squared and the positive 15 at the end. And now when you look at this problem, you can clearly see that you have a quadratic. Okay. At this point in time, when we had a quadratic and we were trying to find the factors, we'd have to use AC method. And in this part, it looks like, yeah, I could start by using AC method. But what are we trying to find? The roots, right? The roots. Do we really need the factors when we're finding the roots?
No.
So what program can I use? Good. Take out your calculators. You wrote the program for a reason. Look in there, run it through your program. Your A value is negative 2, your B value is negative 3, your C value is 15. Run them through your quadratic program, see what you get for your roots, please. See what you get for your roots. No sweat? And 2 points? Oh? Are you rounding for me right now? Or is that the exact value you got? Thank you. So I'm going to use 09 and 59. Thank you. Just to be a little bit more precise here. That's fine though.
And I have to put it on.
Okay? Again, remember, your A value is negative 2, your B value is negative 3, your C value is 15. Run it through your program, see what you get.
You just run at 3.6.
You can round it, that's fine. Okay, you can round it. If you're going to round the bottom one though, this needs to round to 2.1.
2.1.
Okay, not 2.0. If you're going to round this, it's 2.1. Remember, you look at the next one. For this kind of a problem, I'm getting 2 answers. How come again?
Let's try it out.
Because it's squared, good. Now, in the last examples, when we check our answer, we usually go back, we look at the denominator, we see what makes the denominator undefined, we check that, we run it through, check it also. But for this problem, I'm finding the time. So this means after 2 seconds, I'm at a steady velocity. But what does this mean?
Before you start.
Before I started. So if I have a box on the ground, right, and I start pushing it, after 2 seconds it's at a constant velocity. How can I have 3.5 seconds before I start? Is it moving at all? It's not moving at all, so it's not at a steady velocity, it's at a 0 velocity. So when we get a negative time in physics, usually you reject that solution automatically. Because a negative time means you're going back in time. For example, if you have a cliff and you have a projectile fired off of a cliff and you want to find the time it takes to land, this time might be after like 5 seconds. Well, you're going to get a quadratic. So your other answer you're going to get for this would be something like t equals negative 2, which really means the time it would take for the projectile to go back in time, back to here. Which logically doesn't make much sense, because it's a cliff, you can't go into the cliff, right? So for this kind of a problem, we're going to reject the solution simply on the fact that you can't have a negative time. Okay? And let's write that down, please. Our reasoning is important.
So what if it didn't have to do with time, then it would still be.
Then we could still check it and we can go through, absolutely. Just like yesterday. Remember the one with the M's yesterday? We got a negative and a positive answer. We still check them both. But today, since we're looking at a problem with time, time must be considered positive. Again, so our negative answer gets rejected simply because of the problem we're working on. Not because of our check, not because of our restricted domain in the denominators. Again, simply because of common sense or logic. That's why we're rejecting that. Now, I've rejected that solution. So it's not worth my time to go back and test it. So I only have to worry about this now. Before I test this solution, let's look back at our original problem. Our original problem, whoa, there's a lot going on here. Our original problem, we had this in a denominator, and we have this denominator. What would make those denominators 0? Negative 3 here would make that a 0, right? So we know t can't be negative 3. And what else? What would make this a 0?
Negative t, I guess?
Negative.
0.
Just 0. Again, let's look at this, because a lot of people mess this up first period. Here, 5 divided by 0 is undefined. So what would make this 0? Well, if t was just 0, because you plug it right in. So our restricted domain tells us that t can't be negative 3 and t can't be 0. Those are our restrictions to this problem. Again, remember, look at the denominator and say, what would make that 0? Okay, what would make that 0? Now, yesterday it was more complicated. We had to find one that was a little bit different. But here, we can just look by inspection. Anybody remember what does inspection mean? Just by looking, just by checking it out. Very good. So if you give a reasoning for your answer, by inspection, t cannot be negative 3. That's why. If you didn't know that by looking at it, you got to set the denominator equal to 0, and then solve. You get t equals negative 3. So this is the problem, so we write t can't be negative 3. Okay, we could always check by arithmetic, but in this case, we're going to do it by inspection. So we go back. Is our answer negative 3 or 0? No, it's not. So our restricted domain has no effect on this problem, really, because we didn't get an answer that rejects that. So now, once I go down, I see 2.09. What do I have to do as my final step? Plug it in where? The original. The original. Remember, it's always into the original. So the original was this 2 over t plus 3, and this one was 5 over t minus 2. So I'm going to say my original is, again, 5 over t minus 2 equaling 2 over t plus 3. I'm going to take this value, I'm going to plug it in here, and I'm going to plug it in over here, in those two spots. Okay.
So every time when you find a root that is negative, you cancel it?
No. Again, let's make sure we make this clear. We only canceled the negative root here. How come? How come we canceled it here? Because it was time, and time it cannot be negative. But in the last problem, look back at example 4 from yesterday. In example 4 from yesterday, we did get a negative answer. We did get a negative answer there. We had 2 roots, right?
Yeah, we had
Go back and take a look.
3.
Okay, and we didn't reject it right away because it was negative. We might have rejected it because it didn't make sense in our answer when we checked it or when we looked at our restricted domain. The only reason we're rejecting this is because it's time. So if you're given a random problem, for example, quickly look, the next problem, there's no time involved here. So if it's negative, it could be the right answer still. Okay, it's only because it was time. Now, continuing, let's check.
Yeah, it worked.
What do you get when you do this, Karen? I'm plugging in 5 over 2.09 minus 2 equals 2 over 2.09 plus 3.
0.39.
On both sides?
Yeah.
Very good. 0.39 equals 0.39. Now, today I gave the quiz in first period, and a lot of people got an example where it said 0.75 equals 0.74999. People were rejecting it. Again, when you round, you're going to have rounding errors. Didn't we round to 2.09? Wasn't it like a bunch of other numbers that was
It
right?
was like 2.0899.
A bunch of other answers, right, from our roots. So since we're rounding, when we check, there might be a minuscule rounding error. So if you got like 0.39 equals 0.389, it's pretty much the same thing there. So use logic again. If you're rounding, there's a chance that your answer might have a small rounding error. Okay? In this case, it doesn't. We're okay. Remember, if you're typing this in your calculator, you need parentheses around here. Whenever you have a denominator that's adding or subtracting, if you're not going to do that in your head, you got to put parentheses around it. If you don't, it's going to do 2 divided by 2.09, and then add 3 to that answer. Okay? Remember, you need parentheses. Questions so far on this? Okay. I know, you're on the time. Isn't this crazy? Are you on the time up there? Clock's went out this morning. It's right here, yeah. It's 2:55. Clock's went out this morning. They came here, they fixed them. So they fixed the bells. The bells are all on, but the clocks are all off. They're off by 2 hours and, I don't know, 20 minutes? Or, oh no, it's ahead. So they're off by 1 hour and 45 minutes ahead. Okay? Number 6. Number 6.
So, this is the same as example 5, right?
Same one? Start by writing, please. Did you just call me C42? I heard that one up there.
No, her accent señorita.
Okay, we'll see. Right away, what screws up this problem? What makes it undefined?
7 plus.
It b equals what?
Is it variable or something?
It wouldn't do error.
What would make this problem undefined? If b were equal to what number?
2.
2. How come?
Plus 2 minus 2.
Because 2 minus 2 is? 0. Can you divide by 0? So automatically, in the beginning of the problem, start by saying this. B can't equal 2. Again, we can do it at the end of the problem. We can do it at the beginning of the problem. It really doesn't matter right now. When we start graphing, we're going to talk about what this means with a graph. And this is called the discontinuity. But we'll talk more about that next week. Now, that's our statement to start. Let's take a look at this problem. What do I see right away? It looks like you got common denominators of 2 of them, right?
Except 1,
But what's
yeah.
missing here?
Yeah,
B minus
Good. So please start writing and put it as 7 b minus 2 over b minus 2 plus 10 over b minus 2. Again, remember, 7 is really 7 over 1, so we put the 1 there to remind ourselves. Your denominators are gone. We don't need them anymore. Again, if the denominators are equal, the numerators must be equal. So right now we're going to equate our numerators. We get 5b equals 7 parentheses b minus 2 plus 10. Are we all clear so far?
Yeah.
What do I do next?
Multiply 7 distribute
Good. Distribute the 7. Distribute the 7. Go ahead and do that. On the left side, we still have 5b. On the right side, we got 7b minus 14 plus 10.
negative 4.
Okay.
How did we get, what is that, 5 or 9?
Sorry, this is 5b. That's me having bad handwriting, sorry. 5b.
Do you now, like, you got subtract 5 from that one side, that is 0 now.
Okay, so we could try and find a 0 on this side, but when you have a linear equation, just get all the b's on one side, get all the numbers on the other, and then divide. Remember, it's linear. When it's x squared or x to the third, you want a 0 on one side for sure. But here, move the 7b over there, so you get the b's over here, combine like terms over here, and then you can just solve normally. What does this become when I combine these two? Minus 4, please. Now subtract your 7b. Why am I subtracting 7b? Why not add 7b?
You have to have something else.
Sure, but why don't I just add 7b? It looks like there's a minus sign near it.
Oh, but no, because there's a plus.
Positive.
Where is the positive though? I don't see it.
Good.
Good. There's really a plus here, remember that. A lot of people see this negative and they try to add it over here. Remember now, when you subtract it, what's left on this side?
Negative. Oh, equals negative 4.
Negative 4. Negative 4. Remember, your negative sign is attached to your 4.
You divide by 2.
So then divide by negative 2.
And that is undefined.
But take a look. William, a little louder.
It's rejected.
Rejected. How come?
Because b can equal 2.
B can't be 2. We got 2 as our answer. Again, we divide by 2. Divide by your -2, you get 2. But we said in the beginning of the problem, our restricted domain told us that b couldn't be 2. And we got b equals 2. So what happens in this problem?
It's undefined, it's rejected.
It's rejected. So what's our answer then?
It's undefined.
Our answer is not undefined.
It's just rejected.
It's rejected.
It's rejected. Sure, let's write the word rejected. Sure. Well, how would I make a statement about my answer for this problem? What is it? No solution. Very good. Remember, people, if both things get rejected, there is no solution.
So how is it, what is it that's undefined?
Because if you take a look at your answer, it was 2, right, Kelly? Doesn't 2 make the denominator 0, though? So based on that alone, you reject it. Even before you check, try and check it. You're going to get 5 over 0, or you're going to get 10 over 0 equals 7 plus 10 over 0.
Oh, yeah, no,
You can't have 10 over 0, though.
Like, is there ever going to be an answer, like, it's undefined, like you said, undefined, or it's just no solution?
Oh, there would be no solution.
Okay.
Your fractions become undefined, thus there is no solution. Okay, but the answer is not undefined. The answer is no solution. Okay? Are we clear on this?
Yeah.
Good to go?
Yep.
All right. I'm going to stop the recording for the lesson. Let's go over some of the homework.